Hello, my name is Regina and my team is Isabela, Cristina, Sofia, and Ivana. And today Isabela and I, we're going to explain the concept of kinetic energy. Kinetic energy is energy that an object has due to its motion. For example, a moving a car, a throwing ball, or even a person running. All of these have kinetic energy. This energy depends of two main factors, mass and velocity. The faster an object moves, the greater the mass is, the more kinetic energy it has. In everyday life, kinetic energy is used in cars, machines, and even in wind energy systems.
Now I'm going to talk about the history of kinetic energy. The study of kinetic energy started with important scientists. First, Galileo Galilei studied motion and discovered that objects fall with constant acceleration due to gravity. Then Isaac Newton developed the laws of motion, explaining how mass, force, and acceleration are related. Finally, Gottfried Wilhelm introduced the concept of vis viva, that is now what we call kinetic energy, related to mass and the square of velocity.
Now we're gonna do our experiment. This experiment, we use the principle of the kinetic energy and we use the formula of kinetic energy, obviously, that is 1/2 times mass times velocity squared. And then we use the formula of velocity, that is velocity equals distance over time. Now the materials we use for this experiment, we use two different balls of different masses, a ruler and a timer, and a scale.
Now for our experiment, the first thing we have to do is to measure the height that we are throwing the balls. We measure 1 meter from the wall. The next step is to throw each ball 3 times to get an average time of falling. We did this calculation by adding all the numbers that we got and then dividing them into 3. That gave us 0.65 seconds of falling. In here you can see how we throw the ball and then we stop the timer and we repeat that procedure 3 times per ball. The first ball weighs 53 grams and the second ball weighs 2 grams, but we converted that into kilograms. Now we do our calculations. First, we have to get the velocity. Velocity equals distance over time. So, velocity equals 1 meter over 0.65 seconds equals 1.54 meters over seconds. Now that we have the velocity, we have to get the kinetic energy of each ball. As we can see, we have the same velocity for the two balls because in the formula for velocity, there is no mass acting. So it doesn't matter if the ball weighs more than the other because mass doesn't matter in this formula. It is important to also reassure that we are not using air resistance or friction in our calculations. And that is why the two balls had the same velocity. Now, the kinetic energy that we get from the first ball, which weighs 0.053 kilograms, was 0.06 joules. Now, the kinetic energy for the second ball, which weighs 0.002 kilograms, was 0.00 joules. This happens because our second ball was really light.
With this, we observe that the heavier ball produces a stronger impact, which means it has more kinetic energy. We also observe that the two balls have the same velocity because they fall from the same height, and which this demonstrates that mass influences directly kinetic energy. In conclusion, we learned that kinetic energy depends on both mass and velocity. Even if two objects fall from the same height and have the same velocity, the object with greater mass would have more kinetic energy. This concept is important because it helps us understand how objects move and how energy is transferred in the real world.